Chapter number 13, Probability. Now, probability you already studied in 10th as well as 11th standard. So before I get into probability which is discussed in this chapter, which is about conditional probability, I would like to just recap what you did earlier. So if you just recall, you did sample space, then you have studied events, various type of the events and so on, and then you have defined probability P of A, that is, we know number of outcomes in the events A, number of outcomes in A upon total outcomes in the sample space. Total outcomes in the sample space. Outcomes in S, which is the sample space. So sometimes it is also expressed like this: R by N, P of A, for any event A. If we just express in form of symbol, so here let's take this rectangle as universal set or the sample space as this is an event A. So total outcomes in this one, that is N, number of outcomes. So number of elements in the sample space is small n, and this event A, that is number of outcomes in the event A, that is small r. So ratio of these two, R by N, number of favorable outcomes upon the total outcomes in the sample space, which is defined as probability of the event A. Right? Event, you know, it is a subset of the sample space S here, which is one type of the percentage only, which we know we already discussed earlier. Number of favorable outcomes, that is number of outcomes in the event A upon total outcomes in the sample space, which is R by N. Now, even you did this results also, so I'll just state the results about probability. So one, that is, we know probability of any event is always greater than or equal to 0, less than or equal to 1. For any event A, we know this. For any event A, probability is given by this. We also know probability of the sample space is always 1, and probability of impossible event is 0, 5. Impossible event is 0, 1. Probability varies from 0 to 1. Then we have this addition rule for probability. Probability of A union B, we know it is given by P of A plus P of B minus probability of A intersection B for any two events. And for three events, that is P of A union B union C, that is, we know P of A plus P of B plus P of C minus A intersection B minus B intersection C minus C intersection A plus A intersection B intersection C. This is addition rule for three events. We also know that if events are mutually exclusive, then this term will be 0, all these are 0. Mutually exclusive means intersection equals to 5. So this is addition rule for two events, this is addition rule for three events. You know all these things. Then one more important result here, fourth one, that is probability of A intersection B dash. P of A intersection B dash. We know this is same as P of A difference B. which is nothing but the P of A minus P of A intersection B. We know this very well. Probability of A intersection B dash. This is sometimes called only A. And the same way, probability of B intersection A dash, which is probability of B difference A, which is P of B minus P of A intersection B. Right. This also we are aware with. One is this, the other one is this. B intersection A dash, A intersection B. One is this, second one is this. And fifth one, probability of A dash complementary event is 1 minus probability of A. These are the basic results which we know from 11th standard or earlier discussed result. Just to remind you, are stated here. We'll use also somewhere. Fine. Now we come to main topic of this chapter, which is about conditional probability. This is beginning of this chapter. Conditional probability. That's the beginning of this chapter. Conditional probability. So to discuss this conditional probability, I'll take simple example. So let's take S equals to this sample space. Sample space of tossing coin twice. These are the outcome. When coin is tossed twice, coin is tossed twice. This is a sample space. When coin is tossed twice, this is a sample space. Under this sample space, I'll take two events. Let's take event E as this. Event means subset of this sample space. I'll take HH, HT, TH, three outcomes. One more event, HT, TH and TT. These are the two events of this sample space. Now what I'll do, I'll ignore this sample space right now. I'm not going to consider these as a sample space right now. I'll take E as a sample space. Okay, I'll take E as a sample space. So how many outcomes are there? Definition of probability. To find the probability, total outcomes in the sample space, that is N. So here, how many outcomes are there under this sample space? Consider these as a new sample space or sample set. How many outcomes? 3 upon 3. Under this sample space, I'll find the probability of F. Probability of F. Remember, but under which sample space? Considering E as a sample space. So I'll put the standing line and I'll write E here. This is read as probability of F given the event E. That means event E has already occurred. How do we read this? This is read as probability of F given the event E. Given the event E. That means event E has already occurred. I repeat, what this symbol says, it's not division symbol, it is just a standing line. Right? What's the meaning of this? You are finding the probability of E only, but the you are finding the probability of F only, but here you are taking E as a sample space. Now, under this sample space or sample set, probability of F. Now when you recall, when you find the probability of any event, you need to find the common. See, common in this rectangle and the circle. That is R. Number of outcomes means common in circle and rectangle. So common in these two. How many common in these two? One is, this is not the common. One is this and the other one is this. There are two common. So 2 by 3. This is the required conditional probability. This is called conditional probability. Conditional probability. Conditional probability of f given the event E. That means this is no more now sample space. S is gone, remember. You are considering E as a new sample space, and under this sample space, so that's the condition now. That's why this is called conditional probability. Under this sample space, you are finding the probability of occurrence of F, remember. So out of these two, you need to see how many of them are favorable outcomes. So these two are favorable. So two total outcomes in this sample space, which is nothing but how much? 3. So we have 2 by 3. This is called the conditional probability of F given the event E. That means that event has already occurred. Right? So this is just a standing line. Fine? So here what you can do, if I write further, let me write like this. Suppose this event E has occurred here first, and this is event F like this. Fine? So when you find the probability of F here given the event E, what you need to do? You need to write the number of outcomes in the sample space E first. So n of E. And then what you are going to do? You are going to choose common. Common means what? Number of elements in F intersection E. Okay, that's what I did. You see, I've chosen the common. What are the common here? These two. Now what I'll do? I'll divide numerator and denominator by n of F intersection E upon total number of elements in the sample space, main sample space. N of E upon number of elements in the main sample space. Now if you just go back to beginning, this is nothing but the probability of F intersection E upon probability of E. So this is now definition, probability of F given the event E. So this is the first formula. Right. This proof is not important. I've just explained for your information. How do we read this? How do we read this? This is nothing but, this is read as probability. This is read as probability of event F, which is sometimes called the conditional probability, given that event E has already occurred. Event E has already occurred. So you are considering E as a sample space. So total number of outcomes in E, and in turn you have probability. Okay? This is read as probability of F under the influence of E. That means F depends upon E, remember. And how do we get this? By this formula, probability of intersection of these two upon the probability of this one, right? The only important thing is here, this become the sample space. When you do in general probability, when we are defining in the beginning simple probability, then the S is the sample space. You are writing R. Actually, what is this R? That is common in these two. Concept is same at both the places. R is what? Number of elements common in sample space and event A. That is R, and upon total outcomes in the sample space. So what we are doing here, we are considering E as a sample space. So how many members are there? 3. And then probability of F means what? Out of outcomes in F, how many of them are in the sample space? This is not there even in sample space, so you cannot consider these two. You need to take the common. These two are common. So therefore 2 by 3, that's a required probability. Not by 6, not by 4. 4 will not come here, remember. Okay. One is this. Now same way you can define this also, probability of E given the event F. So F has occurred first, right? Under the occurrence of F, you are finding the probability of E. What's now definition? Probability of F and the numerator is just intersection, E intersection F. This is the definition. Here P of E should be non-zero, otherwise this is undefined. Here P of F should be non-zero. So these two are called conditional probability. I hope this is clear to you. Probability of F, आप F का ही probability find कर रहे हैं, but considering E as a sample space, and which is given by this expression intersection over probability of E. You are finding the probability of E here, but considering F as a sample space. So in the denominator you have P of F, and in the numerator you have the intersection. Numerator at both the places it's intersection. Both are same here. And here F is the sample space, here E is the sample space. These two, these and this, probability of E given the event F, probability of F given the event E are called conditional probability, are called conditional probability. Conditional probabilities. Fine. So you need to remember these two. One is this, the other one is this. These two are called conditional probabilities. I'll take one more example so you can understand further. Let's take one more example. Let's take the sample space equals to tossing a die once. You know this 4, 5, 6. This is the main sample space. Let E be an event 2, 3, 4 and 6. Fine. And F be an event. I'm taking, let's take 1, 2, 3. Now my question is here. My question is find this probability of E given the event F. So you are finding the probability of event E under the occurrence of event F. So event F has occurred first, remember. How many? So this becomes the sample space. How many outcomes are there? 3 total. You know definition of any probability. Definition of any probability is what? Total outcomes upon favorable outcomes. So how many total outcomes under this sample space? 3. Okay. Now you are not taking these as a sample space. You are taking F as a sample space. So for event E, out of members of E, how many of them are present? One is 2 and the other one is 3. Got it? In short, intersection of these two, that is 2 by 3. Okay. One more let me do. Probability of F given the event E. That means event E has occurred first. So now this becomes sample space for us. Okay, E becomes a sample space. How many outcomes? 1, 2, 3, 4. So upon 4, because that's the sample space for it. Now probability of F means for F, how many outcomes are common with the sample space? That is again 1 and 2. So 2 by 4, which is 1 by 2. Fine, understood. So I did it directly. Even you can use the formula also. See, or probability of E given the event F. What's the definition? P of E intersection F upon P of F. Okay. Can you tell me what is P of E intersection F? This is not the conditional probability now. Remember, this is our simple probability. So how many members are there in intersection 2? Now for simple probability, you need to take main sample space. So by 6 upon. Probability of F means what? How many outcomes are there in the sample space? 3 upon total number of outcomes in the main sample space, which is 6. So 6 with 6 will get cancelled. You will get the 2 by 3. This is by formula. Okay. Same way, probability of F given the event E. So P of F intersection E upon P of E. Now what is the intersection? As I did in the previous, 2 by 6. Probability of E means what? How many members are there in E? 1, 2, 3, 4. Upon total number of outcomes in the sample space, main sample space, because these are not conditional probability. Main sample space has 6 outcomes. 6 will get cancelled, 2 by 4, so 1 by 2. That is required probability. Let's see one more question. 10 cards numbered from 1 to 10 are mixed up thoroughly. One card is selected at random. So out of 10, one card is selected at random. If it is known that the selected card is having the number more than 3. So this event has occurred. Okay, let me call that as event E, for example. Which event? That the selected card is having the number more than 3. So more than 3 means which numbers? 4, 5, 6, 7, 8, 9 and 10. Out of 10 numbers, more than 3. So this event has occurred. Known, that means this event has occurred. What's the probability that it's an even number? I'll call that as event F. The selected number is even. Okay, so here required probability equals to probability that the selected number is even, that is F, under the occurrence of the event E. Fine, you can use definition. I'm just writing directly here. You are finding the probability that the selected number is even, which are called event F. Given that means, or it is known, that means this event has already occurred. So under the influence or occurrence of this, that is conditional probability. So this becomes the sample space for us. How many outcomes are there in the sample space? 7. 3, 6 plus 1, 7. Out of this, how many of them are even numbers? So 1, 2, 3 and 4. So 4 by 7. That's conditional probability. So there is no role of your 1 to 10. Remember, this sample space. Main sample space is this 1, 2, 3 up to 10. That I have not used. We have used mainly this. I hope now this is clear to you. Now we have results we just state without proof about conditional probability, which are same as what I have stated earlier. The one is the addition rule, probability of A union B given the event E, conditional probability, which is probability of A given the event E plus probability of B given the event E minus probability of A intersection B given the event E. That's similar to what we have stated in the beginning, addition rule for two events. Probability of A union B given the event E, that is P of A plus P of B minus P of intersection B, every time you have conditional probability. Same rule you can state for 3 events also. It can be proved, remember. Second one, that is probability of F dash given the event E, complementary event, which is 1 minus probability of F given the event E. Same what we have stated in the beginning. So we have 2 simple results. Probability of F dash given the event E, it is 1 minus probability of F given the event E. Now I think with this probably we can solve the next exercise. So we'll go to next exercise 13.1. 13.1, first question. We are given P of E, P of F, P of A intersection F. The question is get the probability of E given F. So we know it is E intersection F upon P of F. What is intersection? It is 0.2. What is P of F? 0.3. So it is 2 by 3. Probability of F given the event E, which is again by the formula intersection upon probability of E. What is intersection? It is 0.2. And what is P of E? It is 0.6. So 2 by 6, which is 1 by 3. Next question, you you are asked to find P of A given the event B. So we write intersection upon P of B. You have both intersection as well as P of B. Place the value and simplify. Question number 3, third question. In the third question, you are given P of A, which is 0.8, P of B, which is 0.5, and P of B given the event A, which is 0.4. So if you use the formula here, P of A intersection B upon P of A equals to 0.4. P of A, you know, it is 0.8. So I place here. So P of A intersection B equals to 0.4 into 0.8. So it will be 0.32. This is the intersection value from the given data. And now you can answer all the 3 sub questions. This is answer to, in fact, the first question. That's what you are asked. And the first question, you have this. The other 2 questions, I'm sure you can do it. Fourth is also a very simple question. There you are asked to find union. So you need intersection. So that using A given the event B equals to 2 by 5, use the formula. This is P of A intersection B upon P of B equals to 2 by 5. So from this, you know P of B. What is P of B? It is 5 by 13. So we'll get the A intersection B from this. That is 2 by 5 into P of B. If I take on the other side, it will be 5 by 13. So from this, you will get the 2 by 13. That is value of intersection. And then you can get the union. So therefore P of A union B equals to P of A plus P of B minus P of A intersection B. Now we know everything here. What is P of A? Look at it given data. P of A will be 5 by 26. Just see the given data. What is P of B? 5 by 13 minus intersection, that is 2 by 13. So you simplify, so we'll get the answer. Fifth is the same question. We'll go to sixth question. Question number 6. You are given some events. A coin is tossed 3 times. That's the sample space. And you are asked to find there in the 6th question conditional probability of E given the F. Not only in 6 to 9th, in all these 4 questions you want to get this conditional probability. 6 to 9, in these questions everywhere you want probability of E given the F. So you can do directly or you can use the formula. Choice is yours, whichever way you want to do. I'll go to 6th first. What is their main sample space? That is coin is tossed 3 times. So here this S, you know, it is this HH, then HHT, then HTH, you know, THH, then you have TTH, then THT, then HTT and TTT. These are the 8 outcomes in main sample set. Okay, what is event E here? That is H on the third toss. H on the third toss. So one is this. Here we have H. Here T. Here H. So H T H. Here also H. T H H. Here also H. That is T T H. H, 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 H. In third toss, there should be H. 1, 2, 3 and 4. What is event F? Look at that F. What's the definition of F? Head on first two tosses. Heads on the first two tosses. The one is this HHH. Then HT, HHT. Not this, not this, not this, not this, not this. Only two outcomes. These two. Heads on the first two tosses. Now you want this. So event F has occurred first. E intersection F. So F is the sample space upon 2. Now out of these two, how many of them are common? One is this and this is not. So just 1/2. This is the required probability. Please have a look on it. I hope this is clear to you. Right. Or if you don't want to do, you can do like these also. Both are the same thing. Probability of E over F equals to probability of E intersection F upon probability of F. Now here there is more to understand than to write. What is probability of E intersection F? So look at that intersection. There is only one element common. Main sample space has how many outcomes? 6 outcomes. So what's the probability of this? 1/6 upon F. F has how many outcomes? 2 outcomes. Main sample space has 6 outcomes. So we have 1/2. This is another way. You can write directly like this or that like this, whichever way you like. I hope this is clear to you. Okay. I'll go to third sub-question there. In the same question, third sub-question. Let's see there. Event E is at most 2 tails. At most 2 tails. That is, number of tails should be 2 or more than 2. Number of tails, 2 or less than 2. Tails should be maximum 2. At most means maximum 2. So number of tails can be 0, 1 or 2. So what are the favorable outcomes? At most 2 tails means maximum 2 tails. So I'm just concentrating here. Right. So from this, all these outcomes will be there. This will not be there. So this HHH, no tails. HHT, 1 tail. HTH, 1 tail. THH, 1 tail. TTH, 2 tails. THT, 2 tails. HTT, 2 tails. 7 outcomes. Fine. Now F. Therefore E is this. What is definition of F? At least 1 tail. Definition of F is at least 1 T. At least 1 T. That is, number of tails must be 1 or more than 1. Number of tails must be 1 or more than 1. So either 1 tail or 2 tails, all the 3 tails. Here 1, 1, 1, 2, 2, 2 and 3. Except HHH, all will be there. So these are the outcomes. HHT, 1 tail. HTH, 1 tail. THH, 1 tail. Then TTH, 2 tail. THT, 2 tails. HTT, 2 tails. And all are tail, 3 tails. Number of tails should not be 0. Right? All these were writing up from the main sample space. Okay. So probability of E given F. Here F has how many outcomes? 7 outcomes. So upon 7. Now intersection of these two. So intersection will have here, what are the outcomes in this intersection? You have 1, 2, 3, 4, 5. And this one 6. 1, 2, 3, 4, 5 and 6. These two are not common. So 6/7. Or you can write, I'm just writing for your information. You can use the formula E given the event F. You write intersection E intersection F upon probability of F. Now what is intersection? That is 6. But main sample space has how many outcomes? main sample space has, oh sorry, I'm sorry, this is my mistake. There are 8 outcomes. Main sample space has 8. So even there is a correction here, 8, 8. Final answer will be 1 by 2. So here, this is 6 by 8 upon, this is how much? 7 by 8. So 8, 8 will get cancelled. So 6 by 7. Okay, please correct this. This is my mistake. There are 8 outcomes. I wrote in the beginning 6, which is wrong. So 1 by 8, 2 by 8, so 1 by 2. Final probability is this only. Okay. Now, even if I do reverse, this is not asked. Probability of F given the event E. These also you can do. So event E has occurred first. So how many outcomes? You can see 7. There are total 7. Out of them, how many of them are common? 6. So final, again it will be this much only. 7th question. 2 coins are tossed once. So what's the sample space? You know, 2 into 2, 4 outcomes. N equals to 4, main sample space. And these are the outcomes. HH, HT, TH and TT. The earlier question was about 3 coins. Question number 6. Okay. I'll do second sub question here. What is definition of event E? No tail appears. No tail. No T. So E has only one outcome, HH. No tail appears. Only HH. One outcome. And what is definition of F? No H. No H appears. This is given to you in the question. No H. So only this one. TT. So here what you want? The question is conditional probability. Therefore the required probability, that means this is what you are asked. Probability of E given the event F. E given the event F here. So what do you think? So total number here, F becomes the sample space. Total outcomes in the sample space 1. What's numerator? Common in this 2. Is there anything common in this 2? No, 0. So the probability is 0 here. The conditional probability is 0. This means find the probability of getting no tails when, E or no tails when no edge has appeared. That's a question. So as per our definition, required probability is 0 here. First you can try. I hope you can do that. Question number 8. There a die is thrown 3 times. Okay. So you know, if die is tossed once, if it is tossed once, you have the 1 to up to 6 outcomes. If it is tossed twice, you have 6 into 6, 36, and thrice, then you have 6 into 6 into 6, that is equals to here, so 216. So main sample space is this. Like this you can write x, y, z, such that x runs from 1 to 6, y also runs from 1 to 6, and z also runs from 1 to up to 6. Okay, so this is the main sample space. What is definition of event here? N is this, remember, total 216, which is not important. Let's look at definition of E. What is definition of E here? 4 appears on the third toss. So E will be this. X, Y can be anything, but this 4 is fixed, where X, Y are from 1 to up to 6, remember. So this will be total 36. This is fixed, given to you, that the 4 appear on the third toss. This is fixed. XY can be anything. What is definition of F? 6 and 5 appears respectively on first two. So 6 is fixed, 5 is also fixed. This can be anything. So here Z can be 1 to up to anything. I hope you can understand this. See, what is definition of E? 4 is fixed. 4 appears on the third toss. So X and Y can be anything, 1 to up to 6. 6 and 5 appears respectively on the first two. So Z can be anything. Z varies from 1 to 6. Now what you want? What's the question? Question up to 9th, probability of E given the event F. So event F has occurred, remember. F has how many outcomes? Can you tell me? F has how many outcomes? Yes. You know F has total how many outcomes? 6 outcomes. Because here Z can be 1 to 6. So number of outcomes in this one is 6. So upon 6. Fine. Now question comes to common in this two. Can you predict how many common? You see here 4 is fixed. Now how many times 4 will occur over here? Only one time. Here XY are fixed 6 and 5. How many times 6 and 5 will be occurring in this? Only one time. So I suppose there is only one outcome common in this, that is 1 by 6, like this. E intersection F, this is just for it, has only one outcome common, that is 6, 5 and 4. So number of outcomes in this one is just 1. That's why we wrote 1 here. And number of outcomes in F, Z can be anything. So 1 to up to 6. So there are 6 outcomes. So that's why this. Or you can just write like this if you want. Probability of E intersection F, which is probability of E intersection F upon probability of F. E intersection F has one outcome. Total number of outcomes in the sample space 216 upon F has 6 outcomes upon 216. So 1 by 6, that is required probability. 9th question. Mother, father and son. These 3 line up at a random 4 family picture. So it is arrangement of 3 objects, 1, 2 and 3. So it's a question of permutation. How many ways 3 objects can be arranged internally? You recall it is 3p3, 3 factorial. So there are 6. So this is main sample set. It has 6 outcomes. You can list out MFS, then MSF, then you can write SMF, then you can write SFM, then now you can take FSM and FMS. So these are how many outcomes? 6 outcomes, 3 factorial. Your number of objects are just 3, so you can list this. If you have 10 objects, then it's difficult to list. So this concept can be used. This is the main sample space. 3 factorial, that is 6 outcomes. So here event E, that is sun should be at the end, one end. So you have, if you just look at it, sample space, one is this outcome, the other one is this. Now it can be SMF or it can be SFM. These are the 4 outcomes for event E. For event F, you are given that F is in middle. So there you have just have a look at given sample space MFS and SFM. Only 2 outcomes. So probability of E given the event F. So F is sample space here, total 2. 1 and 2. It's 2 by 6 actually. Main sample space has 6 outcomes. Now out of these 2, how many of them are common? So one is this and the other one is which one? This one. These 2 are common. So it is this, or if you want you can write here 2 by 6. Main sample space, you know, it has 6 outcomes. Here also 2 by 6. So 1 is the required probability. 10th question. A black and a red dice are rolled. So 2 dice are rolled. 2 dice are rolled, are tossed. One is black, that color is not important, and the other one is red. Okay, so here 6 outcomes, here also total 6 outcomes. So total we have 36 outcomes in the sample space. So this is main sample space. For example, I'll write B. Normally we write X and Y, but here you are given black and red. So B and R. Such that where B varies from where to where? 1, 2 up to 6. And R varies from where to where? 1, 2 up to 6. This R can be any one of the 6. B can be any one of the 6. So therefore you have 36 outcomes. Okay. Now read the first question. I'll do first only. Find the conditional probability of obtaining a sum greater than 9. So I'll call that as, for example, event E, that the sum is more than 9, more than, greater than 9. So summation should be 10, 11, or maximum it should be 12, 6 plus 6. So what are the outcomes? Summation should be 10. So it starts with 5, 5. Summation is 10. Then you can have 5, 6. Then you have 6, 5, 11. And finally you have 6, 6, which is 12. These are the outcomes of the event E. Sum is more than 9. It's written clearly. Obtaining a sum greater than 9. Greater than 9 means either 10 or 11 or 12. This you know, such things we had even in 11th. Event E. And now event F, the other event. This event has occurred given that. So that event means what? The black die result in a 5. So this is fixed. So black one is a 5. This is fixed. So here this number is fixed. So what are the outcomes of F? This is fixed 5. Black is fixed 5. R can be any one of these 1, 2, 6. So 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, and 5, 6. Clear? I repeat. See what is given in the second event. F, the black is fixed 5. So you are not going to change this 5. 5, 5, 5, 5, 5. What about here? R can be any one of the 1, 2, 6. So this is 2, 3, 4, 5, 6. Fine. This event has occurred. Read the question. Given that the black die result in a 5. Given that means that event has occurred. So here in the first one, you have required probability. Which event has occurred first? Event F. So I'll write F here. And then the probability of the event E. Event E means what? The summation is more than 9. The probability of the event that the summation is more than 9 given that the black die has 5. Now use the definition E intersection F upon probability of F. What's the probability of F? You have total how many outcomes? 6 and total 36. So if you want you can write 6 by 36. Now just get the intersection. What are the intersection members here? One is 5 comma 5, then 5 comma 6. 6, 5 will not be there. Only 2 are common. 1 and 2. 1 and 2. Only 2 are common. So what is this here? 2 by total outcomes 36. 36 will get cancelled. So we'll get the 1 by 3. 2 by 6, which is 1 by 3. That is required probability. Second, I will not do. You must try. I hope you now have understood the concept of the conditional probability. Question number 11. It's very simple question. A die is rolled once. So main sample space has the 6 outcomes. So n equals to 6 here. Then you are given some events. You are given E, which is 1, 3, 5. You are given F, which is 2, 3. These are the events. And you are given G also. What is event G? That is 2, 3, 4, 5. Fine. Now I'll do all our very simple question. I'll just do third one. Probability of E union F over G. There are number of ways of doing this. I'll use that property. Probability of E given the event G plus probability of F given the event G minus probability of E intersection F given the event G. I've used one of the property if you remember. Okay. Now what is E given the event G? Now G became the sample space. It has how many members? 4. So I'll write upon 4, main sample space has 6. So 4 by 6. F. So in common of these two, how many common in these two? 3, 5, 3, 5. So 2 by 6. So this is 2 by 4, which is 1 by common. Remember, E intersection G, 3, 5, 3, 5 plus upon G. What about event G here? That is again 4 by 6. F intersection G, common in this 2, 2 and 3, 2 and 3. So 2 by 6 minus upon G. So G means this event, which is 4 by 6. And intersection in all this, E intersection F intersection G, intersection of all this. Is there anything common? 3, I suppose it is common in all. 5 is in this but not in this. 3 it is in this. 2 it is in this but not this. Just 1. So 1 by 6. So you have 2 by 4 plus 2 by 4 minus 1 by 4. So this is how much? Finally 3 by 4, which is here required probability. In third sub question you are asked one more thing. That is, I think this one, this portion. Right? This one only you are asked. Probability of E intersection given the event G. So E intersection F intersection G upon probability of G. So 1 by 6, 4 by 6. So their answer is just 1 by 4. That is second part of third sub question. 1 by 4. 12th question. A family has 2 children. So you know, for a single child, either boy or girl. This for second child, again boy or girl. So total you know, boy, B, G, G, B and G, G. These are the 4 outcomes. This is the main sample set, 4 outcomes. What is the probability that the both are girls? So I'll take that as event E. Both are girls. You want the probability of this. So both are girls means only one outcome. Here event E is this. I've called both are girls as event E. Anything you can call that, labeling is not important. Both are girls. First question. Now this is a conditional probability. Given that youngest is a girl, so I'll call that as F. The youngest child is a girl. Youngest child means firstborn child. So F has here F is a girl. So one is this, second one is this. GB, GG. Youngest means firstborn child should be a girl. See here you can think like this also, or you can write like this also. You can consider second one also. Then GG will be there. Instead of GB, you may have BG like this. Number of outcomes and the final answer remains same. Either this or this. Both are same, remember, as far as final probability concerned. So here for first question, required probability, that is the probability of the event E, given that means this event has occurred, F, given that the youngest child is a girl, this event has occurred. So this is a conditional probability, not F over E, it's wrong symbolically, remember. Given that comes down after oblique symbol, standing line. Now what is this? E intersection F upon probability of F. What is there in intersection? Intersection will have one common and total there is 4. So 1 by 4. Probability of F, your total 2, whether it is this or this, 2 by 4. So finally it is 1 by 2. Right? So this is answer to first sub question 1 by 2. Same way you can try the second one. I'll go to question number 13. Question number 13, I'll express the given information in form of table. So we have two types of the question. One is true false and the other one that is MCQs. In true false we have easy and difficult. So now let's read the question. There are 300 true false questions which are easy, 200 difficult true false questions, MCQs 500 easy and 400 difficult. Okay, so here we have in MCQs 500 easy, so this will be here. Okay, so here total 500, MCQs total 900, total number of questions which is 1400. So actually here n is 9 plus 5 which is 1400. There are 1400 MCQs. Okay, now what is the question? Now I'll define as per question events. So what's the probability that it will be an easy question? So let E be an event that it is an easy question. And which event you already given? That it will be an easy question given that it is a multiple choice question. So I'll call that as M. This event has occurred. Multiple choice question. Okay, and what we want to find? We find this is the required probability. Probability of an event E given the event M. This is the question. It's an easy question given that means this event has already occurred. Now what is the definition here? It will be P of E intersection M upon probability of M. This is the definition of conditional probability. Now E intersection M means what? It should be easy and it should be MCQ. So can you see in this table? Easy and MCQ. So how many? 500. It should be easy. So this one and MCQ. So 500 and total 1400. So here if you want to write it is 500 by 1400 upon now MCQs, total number of MCQs. How many MCQs? Here 900. So 900 by 1400. So 1400 will get cancelled. So finally you are just left with 5 by 9, which is required probability. So here this tabular data is very important. This data is very important. From this data you could answer both the question. And finally the required probability of the event E, that is it was an easy question and given that it was an MCQs. So question number 15, 14 for you, you can try. Let's see what the experiment says. Consider an experiment of throwing a die. So you have 6 outcomes. There are 2 possibilities. If multiple of 3 is obtained, that is if you have 3 or 6, then throw a die again. So you have 1, 2 up to 6. So if you combine both the things here, the outcomes will be like this. In this case 3 1, then 3 2 up to 3 6, then 6 1 6 2 up to 6 6, like this. 3 with this, 6 with this. So here 2 into 6, 12 outcomes over here. Read further. If any other number comes up, what are the other numbers when you throw a die? 1, 2, 3 already taken, 4 and 5. These are the remaining number. 3, 6 already taken. These are the remaining. Then what we do? Read the question. Toss a coin. So in this case, head and tail. So what are the outcomes here? 1H, 2H, 4H and 5H. Here 1T, 2T, 4T and 5T. So total in this case we have how many outcomes? 8. So total sample space will have 20 outcomes. 12 plus 8. This is just for your information. Now what is asked? I'll call the first one as event E. What is the definition of an event E? Event that coin shows a tail. Coin shows a tail. Which is event has occurred? So event F, at least one die shows that 3. At least one die shows 3. This is event F. Now this event has already occurred. Given that means this has occurred. So required probability equals to probability of event E given the event F. So this is equals to, you have P of E intersection F upon probability of F. Now see here, E intersection F means there should be at least 3 and tail. Now if you observe here, with tail you never have 3, either 5, 4, 2, yeah 1. That means this intersection will have 0 outcomes. Upon probability of F, whatever it is, that also you can find, but the final answer will be obviously 0. Now question is, what's the probability of F? Let's write that. So that you can answer from here, at least one die should have 3, at least one die should have 3. So in all these you have 1, 3, 6 outcomes, and somewhere here also you have 6, 3. So 6 plus 1, so here this is total 7 upon main sample set 20. So this is 7 by 20. So finally you will get the 0 only. Okay, now the next 16th you are asked to find P of A given the event B. So which is P of A intersection B upon P of B. But in the question itself you are given that this is 0. So therefore what's the conclusion? Not defined. When we have discussed, we already mentioned that this should be non-zero. So correct option is C here. 17th MCQs here in the last. You are given A given the event B equals to probability of B given the event A. Just write the formula. This is A intersection B upon P of B. This is A intersection B with the probability upon P of A. So here both the numerators will get cancelled. Both are again non-zero. So you have P of A equals to P of B. And that is nothing but the option D.